feel bad that Evan's not here. Hi, Evan, if you're watching. Or if you watch. Because we're not live or anything. Like, live from room 303. What's going on? How are you? Let's take a derivative. Yeah, right? AP review. Oh my God. Turn in. Let's subscribe and hit the like button. All right, so here's what we got. I'm going to ask you questions about f of x. I'm going to ask you questions about f of x. I'm going to ask you questions about f of x. What is this not? This is not f of x. So all of these questions, right, are not referring to the curve that you see. They're referring to the curve that you don't see. The one that was prior to this one. Because this is the derivative of whatever f of x is. Understood? Okay, so on what interval is f decreasing? Well, what's my rule for decreasing? It's where the derivative is less than 0. Does everybody agree with that? Well, guys, here's my derivative, right? Do you guys agree that this is where the derivative equals 0? Do you guys agree that this is where the derivative is greater than 0? And do you agree that this is where the derivative is less than 0? So where is the derivative less than 0? From here to here. So from what? 0 to 1. Okay. Then the derivative is positive. It's all positive. And then from 6 to 8. Right? And what would be your justification? F of x is decreasing where the derivative of f of x is less than 0. Yeah, that would be your explanation. Cool? All right. So at what value does f have a local maximum or a local minimum? Well, in order to do that, guys, what do I need to know? Well, this is where it's decreasing. I also need to know where it was increasing. So yeah, so this is where it was decreasing. All right, so we got that. And then I am increasing where the derivative is greater than 0, right? So would you agree from 1 to 6, all of it, right? And then again from 8 to, no, not infinity, because it said it was what? Closed interval, right? So 1 to 6 and 8 to 9. All right, so from 1 to 6 and from 8 to 9, f of x is increasing where the derivative is greater than 0. All right, so where do I have local maxes and local minimums? I have local maxes and mins where I had what? A change from increasing to decreasing or vice versa, right? So I have a local max and a local min. Okay, so let's figure this out. Ready? Austin, what am I doing? I'm decreasing from 0 to 1, and then I'm increasing from 1 to 6. So what was 1? Local min or local max? Which one did you say first? Min, you're right. Yeah. Because what was I doing? From 0 to 1, I was decreasing, and then from 1 to 6, I was increasing. So there was a change in what? From increasing to from decreasing to increasing, right? Okay. So I have a local min at 1. Oh, hang on a minute. What value of what? X. So yeah, so local min at x equals 1. All right, then what do I do? From 1 to 6, I am increasing. From 6 to 8, I was decreasing. So I went from increasing to decreasing. So 6 must have been a maximum. All right. From 6 to 8, I'm decreasing. From 8 to 9, I'm increasing. So 8 must have been a minimum. Local max at 6, local min at 1 and 8, because the derivative changed from this one was what? From increasing to decreasing. And because the derivative from decreasing to increasing. Everybody go with that? Cool? All right, guys, concave up. Concave up means what? F double prime is positive, right? It looks like a cup, Brandon, but I can't what? I can't see it. So I have to rely on this fact, right? I'm concave up where the second derivative is greater than 0. Here's the problem. Is this the second derivative? No. But guys, what's the derivative at a maximum or a minimum? 0. From here to here, what would be the derivative values, positive or negative? So I want to take the derivative of this curve now, right? Because the derivative of this curve would be the second derivative, wouldn't it? So what is the derivative right here, positive or negative? Positive, because the tangent line would be positive, right? So the derivatives, these are all positives, aren't they? What about up here? It's 0. And then what about from here to here? The derivatives would be what? Negatives. And then this derivative would be 0. And then the derivatives would be positive and 0 and negative and 0 and positive. So guys, all of those blue things that I just wrote down all represent what? The tangent lines to the first derivative, otherwise known as the second derivative, right? So everything in blue is a second derivative. So I said that I'm concave up when the second derivative is greater than 0. Well, where's the second derivative greater than 0? Anywhere that I wrote down what? Positives. So from 0 to 2, from 3 to 5, and from 7 to 9. Zero to 2, 3 to 5, and 7 to 9. State the inflection values. State the inflection values. Where do I have inflection values? When I had changes in concavity, right? From up to down or down to up. So this is where I was CC up. Well, where was I CC? Actually, do I really even need to do that? I mean, why don't we just look at the curve? Pluses went to minuses, minuses went to pluses, pluses went to minuses, minuses went to pluses. So guess what? 2, 3, 5, and 7 are all what? All inflection values. 2, 3, 5, and 7 are inflection values. The inflection values are going to be values of x. Now, if I said give me the value of the inflection point, if I said give me a point, then you could actually take these values and do what? plug them back into an original curve, but I can't get y values because I don't know what the original curve was, right? Yeah. Yes. Yes. Yep. Our inflection values because concavity of f of x changed from CC up to down or down to up. Guys, this next piece, I'm going to tell you right now, you're going to hate, you're going to struggle with. It is a pain. It is difficult. It is tough. Try to sketch the graph. Okay? This is tough, okay? Because I just gave you all of the clues as to what it looks like, right? But then drawing it is a little bit of a pain. Well, here's the first thing that I know. I only really know information between 0 and 9, right? So all right, so there we go. And they give me one fact. They tell me that there's a point that we know at the origin. Okay, so here's what we got to figure out. I'm decreasing on this interval. I'm increasing on this interval. I know local maxes and mins. They're at 6, 1, and 8. So what I'm going to do is I'm going to go to 6. I'm going to put a point up kind of high. And I'm going to go to 1 and 8, and I'm going to put a point kind of low. Now, here's the thing. Do I know which of these minimums is lower than the other? Could they be in the same position? Could this one be higher than that one or vice versa? Yeah, we don't know necessarily where they are, but we know that they are the lowest points on this curve. And this is the highest point on the curve. Okay, so I got that. Now what do I need to do? Well, from 0 to 1, I need to decrease. What about concavity? Well, from 0 to 1, I need to have a what? Concavity of being what? Concave up, right? So from 0 to 1, I'm going to be concave up, and from 0 to 1, I'm going to decrease. So it's got to look like that. Is that concave up? Does it decrease? Okay. All right, so now how about from 1? Let's see. So I'm decreasing from 0 to 1. I am increasing from 1 to 6. Okay, so from 1 to 6, I need to be increasing the whole time. Okay? What else do I need to do from 1 to 6? I need to be from 1, I got to be concave up from 1 to 2, and then concave down from 2 to 3, and then concave up from 4 to 5, and concave down from 5 to 6. What it says, right? Okay, so somebody read that to me again. Ready? I need to be what? Concave up from 1 to 2. All right, so maybe I'll put a point here. Concave up from 1 to 2. Concave down from 2 to 3. Concave up from 3 to 5. Concave down from 5 to 6.
Yeah.
See how we did that? Right? I know I had to get to that point, right? Now again, do I know exactly where this point and this point and this point are? No, but I need to just make sure that I adhere to the facts based on the derivative, right? So again, it's a pain, okay? What do I got to do from 6 to 8? From 6 to 8, I got to be concave down until, from 6 to 7, concave down, from 7 to 8, concave up. Right? Yep. So I'll put a point here. So it said concave down and then concave up. And then lastly, that last piece I had to be increasing and I had to be concave. So what do I have to do with this last piece here? From 8 to 9, I have to be increasing and concave up. How's that? Will that work? Right? And that's how you do it. That's how you do it, right? You find your extrema, right? See if there's any points that you need to and you just play connect the dots, right? You just play connect the dots. Cool? Kind of fun, right, Brandon? Don't you love that? Yeah, I knew you would. All right, so this is a possible sketch of f of x, right? Possible sketch of f of x. They're looking to make sure that every fact that you wrote down here is true down here. That's what they're looking for. Cool? All right, last one. This one won't take us that long, actually. What am I giving you a graph of? Derivative, right? Okay, so same things apply. On what interval am I increasing? Well, I increase when the derivative is greater than 0. So where is this graph greater than 0? From 0 to 2. From 4 to 6. And from 8 to 9.
For example, like 3 to 6. You know how the graph is increasing?
Yes. So you're saying yes. So what do you ask me?
How they add that?
Where is the derivative increasing?
Yeah.
They would say, on what interval am I concave up? Or where is f double prime greater than 0? That makes sense? Yeah. Okay, so in order to answer this, what do I need to know? I need to know where I am decreasing, right? Oh, I'll do the justification in a minute, okay? We'll write the justifications out in a minute. So decreasing, I'm decreasing from 2 to 4. And from 6 to 8. And again, that's what, Brandon? That's where the derivative was less than 0, correct? So where I'm below the x-axis. So where do I have local maxes or mins? I have local maxes or mins that could be at what? 2, 4, and 8, right? Because local maxes or mins occur when? When the derivative equals 0 and where I go from increasing to decreasing or decreasing to increasing, right? So I'm at a local max or a local min when the derivative equals, when the derivative equals 0 and where the derivative changes from positive to negative or negative to positive, right? So what is 2 going to be, guys? Is 2 going to be a max or a min? Well, what did I do? I went from increasing to decreasing. So if I go from increasing to decreasing, it was a max. So I have a maximum at 2. All right. How about at 4? I go from decreasing to increasing. Decreasing to increasing means that 4 was a min. What about at 8? What did I do? I went from decreasing to increasing. Decreasing to increasing means I was at a minimum. So minimum at 8. Guys, where else can local maxims and mins occur? When a derivative equals 0 or when a derivative does not exist. Does the derivative exist at a point of discontinuity? No. So if you look here, guys, what am I doing? This graph is, okay, so what would be the derivative at this value? From the left, I'm what? Increasing. From the right, I was decreasing. So I believe that I had a what? Increasing to decreasing means that I had a maximum at 6. Sweet. Where am I concave down? Well, this is where I'm going to play the what? Plus minus 0 game, right? Because I need a what? I need a second derivative, don't I? So talk to me about my curve. Now what am I talking about, guys? I'm talking about tangents now, right? I'm talking about doing a derivative of this derivative, right? So I am negatively sloped, and 0, and positively sloped, and does not exist, and positively sloped. So where am I concave down? I'm concave down when my second derivative is less than 0. Well, where's my negative signs? From 0 to 3. From 0 to 3. State the inflection values. Well, inflection values occur when I change from concavity, right? I went from negative to positive, so did I change concavity? Yes. I went from positive to positive, so did I change concavity? No. So the only place I had inflection value was at x equals 3. What did it change from? Concave down to concave up. So again, inflection values occur when those two things happen, right? Gotta have both of them. All right, and now what are we gonna do? Now we're gonna play this cool game where we try to play connect the dots, right? Take a minute, see if you can do it. Try to play connect the dots. Again, it's a tough little skill to try, but give it a whirl.